On April 23, 2026, Anthropic turns the Claude code regression fight from rumor into postmortem. Think of this like a flight recorder after a rough landing. Users felt one crash, but the recorder shows 3 systems failing at different times. The hard evidence includes 6,852 session files, 17,871 thinking blocks, and 234,760 tool calls. So, this is not a secret weight nerf. It is a runtime trust crisis inside the product harness. This blew up because Anthropic's April 23rd postmortem turned the fight from rumor into 3 confirmed product layer failures. The root cause moved away from a simple secret weight nerf and toward effort defaults, session memory, and prompt policy. The community evidence still mattered because users saw one broad collapse before Anthropic separated the blast radius into 3 causes. And that is why benchmarks alone did not settle it. The deployed runtime and the model chart were telling different stories. March 8 remains the user-side hinge because that is where power users said deep investigation started feeling shallow and less reliable. Stella Lorenzo is the GitHub issue author who turned that complaint into public evidence by analyzing thousands of Claude code session logs. The postmortem does not validate every community theory, but it does validate the larger claim that deployed product behavior changed. By March 2026, people were no longer reacting to one bad week. They were reacting to a full chronology of trust shocks. February is the baseline. Opus 4.6 enters Claude code with high effort and big agentic coding expectations. On March 4, Anthropic lowers default effort from high to medium, which quietly changes the thinking budget for Sonnet 4.6 and Opus 4.6. On March 26, the idle session caching optimization ships, and a bug keeps dropping older reasoning on every later turn. On April 16, the verbosity prompt lands with Opus 4.7 and later shows a 3% coding quality drop. So, by April 23, the story is no longer one mysterious nerf. It is 3 overlapping failures with fixes completed by April 20. After the postmortem, the first camp says user telemetry was directionally right even if the exact causal theory was incomplete. The second camp says the weights may still be strong while the harness changed the product users actually touched. The third camp says the deepest damage is visibility because every future regression now becomes an attribution fight. Camp 1 is now narrower but stronger. The user telemetry was directionally right that Claude code behavior changed in the field. The postmortem corrects the causal story, but it does not erase the lived symptoms: shallow reads, repetition, and usage burn. That is why this camp matters. External telemetry caught a product failure before internal evals could reproduce it cleanly. CursorBench is Cursor's real session coding agent eval, measuring developer tasks like solution correctness and code quality. That supports model strength, but it does not explain Claude code runtime drift, effort defaults, stale session reasoning, and system prompts are not packaging details. In an agentic coder, they are part of the intelligence path. That is why this side keeps asking for session-level telemetry. Benchmark wins cannot tell you which runtime layer changed. Camp 3 starts after the admission. Users were right that something changed, but they still cannot see enough runtime state to audit the next incident. The deeper problem is visibility. Effort level, reasoning preservation, cache behavior, and prompt policy are still mostly vendor-side telemetry. That is how opacity becomes part of the product failure, because teams start trusting their own drift monitors more than benchmark screenshots. Think of effort like oxygen in a diving tank. Lower it on a hard task, and the whole investigation gets shallower before the answer appears. Then, the session crosses the idle gap, so the cache path starts handling the old reasoning history instead of leaving it alone. The bug clears older reasoning again and again. So, the model keeps acting without the rationale that got it there. At the same time, a short answer system prompt pushes the agent to surface less of its working process between tool calls. From the user's chair, that does not look like cache policy. It looks like the agent forgot, looped, and stopped doing careful engineering. Default effort is the invisible work budget under the answer. Think of it like oxygen in a diving tank. When the reserve shrinks, the whole dive gets shallower before anyone on deck knows why. On March 4, Anthropic moved Claude Code's default effort from high to medium for Sonnet 4.6 and Opus 4.6 to reduce long latency. That trade-off matters because agentic coding needs investigation time. The same prompt can suddenly feel impatient even when the underlying model still benchmarks well. The cache bug is the memory failure that made the timeline feel haunted. Anthropic intended to clear older thinking once when a session sat idle for more than an hour, reducing latency and uncached token cost. The bug kept clearing that older reasoning on every later turn, so the agent repeatedly lost the trail it had already built. To a user inside a long coding session, that looks like forgetfulness, repetition, and usage draining faster than expected. The prompt regression is the quietest failure, which is exactly why it matters. On April 16, Anthropic added a system prompt instruction to keep text between tool calls and final answers shorter, unless the task required detail. That sounds harmless, but a broader ablation suite found a 3% coding quality drop for Opus 4.6 and Opus 4.7. That is why terseness is not just style in an agentic coder. It can change how much planning, verification, and rationale survives between tool calls. CursorBench is Cursor's real-session coding agent eval. It measures developer task outcomes like solution correctness, code quality, efficiency, and interaction behavior. XBOW Visual Acuity is computer-use vision for autonomous penetration testing. It measures whether the model can see interfaces, read visual state, and operate in security workflows. Those scores support the model strength claim, but they do not fully test long Claude Code runtime sessions with idle gaps, tool follow-ups, memory pruning, and prompt policy pressure. So, the lesson is not that the good numbers are fake. The lesson is that scoped benchmarks are incomplete without deployed system regression tests. This is the eval gap hiding underneath the whole incident. Anthropic says internal usage and evals did not initially reproduce the reports because the failures were not simple one-prompt capability failures. They lived in long sessions, idle gaps over 1 hour, follow-up turns during tool use, prompt interactions, and effort defaults changing the quality latency trade-off. That is why the slide matters. A benchmark can say the model is strong, while the deployed agent becomes brittle inside the harness. This stops being internet drama the moment a coding agent becomes part of production work. A team cannot buy only a model name. It needs to know whether the runtime still reads before editing, tests before claiming success, and remembers the rationale across turns. That is why local agent regression suites, session telemetry, and fallback routing move from nice-to-have into risk management. The enterprise lesson is blunt. If the harness can drift silently, the procurement risk is not just model quality, it is operational continuity. The product response cannot be one patch because the failure crossed effort policy, cache behavior, and system prompts. Anthropic says it will broaden evals, ablate prompt lines, add soak periods, improve review tooling, and dogfood the public build more directly. Those are the right categories, but the user-facing question is visibility. Can teams see enough runtime state to trust the next rollout? Until that happens, provider fallbacks and frozen runtime tiers move from workaround to normal engineering strategy. The likely next move is more runtime transparency and more buyer-side hedge behavior. Teams want frozen snapshots, visible effort budgets, session state signals, and clean provider fallbacks when the flagship starts drifting. That matters because the real product battle now sits below the benchmark chart. The winner is not just the lab with the highest model score. It is the vendor that can prove what runtime users actually received. The lasting lesson is not that one model stumbled. It is that hidden runtime changes can erase trust faster than benchmark wins can rebuild it. For coding agents, the model name is no longer the whole product. Effort level, memory continuity, cache policy, prompts, and tools all shape the intelligence users feel. So the real question is not which chart moved. It is whether teams can actually see the runtime they are betting on.